All right, here we are again. Now we're going to talk about the controls. In the previous module, we identified the hazards, and then we assessed the hazards in the previous presentation using the risk matrix. So now we need to do what we're going to do about the hazards, how we're going to control them. Physical hazards controls. Controls, I'm going to move my head down here. To effectively control and prevent hazards, employers should identify and evaluate options for controlling hazards using the hierarchy of controls, which we'll talk about. Use a hazard, identify the option, okay. Use the hazard control plan to guide the selection and implementation of controls and implement controls according to the plan. Develop plans with measures to protect workers during emergencies and non-routine activities. Those have to be taken into account too. Evaluate the effectiveness of existing controls to determine whether they continue to provide protection or whether different controls may be more effective. Review new technologies for their potential to be more protective, more reliable, or less costly. So this is an ongoing program. You're not going to just do this one time and be done with it. You're going to be doing it even for existing processes because things change. You might find more out about it. Maybe somebody got hurt on it, something you didn't foresee. Believe me, that happens, unfortunately. Review sources such as OSHA standards, industry consensus standards, NIOSH publications, manufacturers literature, trade and professional organizations benchmarking. The poultry industry had a safety council, and they had a convention every year, and it was a pretty big deal. And all the safety people went to it, and you had a chance to rub elbows and talk to and compare things with the other people in the poultry industry. Reports from previous efforts or consultants. Sometimes a consultant sends reports in, and guess what? Nobody looks at it. Ask the workers. Talk to your people. Talk to them. Let them know who you are. Let them know that you're there on their side. Okay, because you're really we work for the company, but you're also on the side of the employers because your job is to make sure they don't get hurt. For complex hazards, consult with consultants or OSHA's on-site consultation program. I've used OSHA's on-site consultation program. Sometimes it's kind of like, you get some good ones, you get some bad ones. But before you invite somebody like that onto your work site, I'd make sure that your boss knows about it. Select the controls that are most feasible, effective, and permanent. So what's a hierarchy? A hierarchy is a system or organization in which people or groups are ranked one above the other or according to status or authority. As a safety professional or supervisor, the hierarchy of controls is an extremely useful tool. You should know it by heart. You should really know this thing by heart. This part of it here. All right. You have elimination, which means physically remove the hazard. Substitution, replace the hazard. Engineering controls, isolate people from the hazard. Administrative controls, change the way people work. And finally, PPE, protect the worker with personal protective equipment. Notice the vertical bar on the left. It says most effective to least effective, and it's color-coded to correspond with the classifications there. So elimination, physically remove the hazard. Elimination is the process of removing the hazard from the workplace. It is the most effective way to control a risk because the hazard is no longer there. It is the preferred way to control a hazard and should be used whenever possible. Examples of elimination controls method include purchasing equipment that is not noisy, using a reach pull where feasible for window washing to eliminate working from heights, removing and properly disposing of products that are stored in the workplace and are no longer being used, avoid driving during extreme winter weather conditions. Makes sense. If it's all icy outside, you just don't go there. You've eliminated a hazard, haven't you? Again, that's the elimination. Substitution. If eliminating a hazard is not possible, substitution is the next control method that should be considered. Substitution is the act of replacing something with another thing. In this case, a hazard is replaced with something less hazardous. The hazards and risks associated with an alternative must be thoroughly assessed to determine if it is appropriate replacement. Care must be taken to make sure that the new hazard is actually lower and that one hazard is not being replaced with another that is just as harmful or even more harmful. Examples of substitution: replacing solvent-based paints with a water-based alternative, That's probably pretty common. We had to happen to us in California. We had a parts washing deal with this company. Would come in, they set up a thing, and they would change the solvent out and would wash our parts in it. We didn't have to worry about disposing of everything, and they changed it to a water based. It was fine, still worked. Using a larger granule form of a product instead of a fine powder to reduce dust generation. Using electric motors rather than diesel ones to eliminate diesel exhausts. Use wet methods rather than dry when drilling or grinding. Wet method means that water is sprayed over a dusty surface to keep dust levels down, or materials mixed with water to prevent dust from being created. Of course, you don't water and spraying it, so you want to be careful if you're doing electrical stuff. You have to be careful that the water doesn't create a hazard. Use steam cleaning instead of solvent degreasing, but be sure to evaluate the potential high temperature hazard being introduced, such as heat stress. Instead of conventional spray painting, try to dip paint with a brush or use airless spray painting methods. These methods will reduce the amount of paint that's released into the air, decrease the temperature of a process so that less vapor is released. But instead of carbon tetrachloride, which causes liver damage and cancer, you use trichlor, 1,1 trichloroethylene, which I don't know, I think it's pretty hazardous too, but I guess not. Benzene, use toluene. Pesticides, use natural pesticides. Organic solvents, use water detergent solutions. Leaded glazes, paints, pigments, versions do not contain lead. That's probably pretty old school there. Sandstone grinding wheels causes severe respiratory illness through silica. Synthetic grinding wheels, such as aluminum oxide. Remember, however, you need to make sure that the substitute product will not cause any harmful effects, and to control and monitor exposures to make sure that the replacement product is below occupational exposure limits. Another type of substitution includes using the same chemical, but to use it in a different form. For example, a dry, dusty powder may be a significant inhalation hazard, but if this material can be purchased and used as pellets or crystals, there may be less dust in the air and therefore less exposure. This is a handy little chart. I thought the least hazardous would be an ingot of something, a solid piece, and then decreasing particulate size would be a pellet, and then a flake, and then a powder, and then a fume. So decreasing in particulates, increasing the particulate size makes it less hazardous. Obviously, you can't inhale an ingot, a pellet, or a flake, but maybe a powder and a fume you can. Certainly, elimination is the best way to deal with a hazard. Substitution can be a good way to deal with it, being careful that the substitute isn't worse than the original. Both of these, but particularly elimination, are best utilized in the early or planning stages of a project where many options may still be open. So there's your hierarchy of controls again. And we've talked about elimination, physically remove the hazard, substitution, replace the hazard. Now guess what's next? Engineering. Engineering controls isolate people from the hazard. Engineering controls are methods that will remove the hazard at the source before it becomes in contact with the worker. Engineering controls should be built into the design of a plant, equipment, or process to minimize the hazard. Engineering controls are a very reliable way to control worker exposures as long as the controls are designed, used, and maintained properly. Examples, machine guarding. This is the number one on the hit parade, believe me, machine guarding. Separate workers from the hazard by the use of physical barriers around the moving parts of machinery and equipment. Now, you'll see this all over the place. It should be built into most equipment. So machine guarding, now, can machine guarding be circumvented or taken off? Of course it can. Almost anything like this, anything can be defeated, anything that's physical. But a properly installed machine guard, which usually has some built-in things that prevent people from taking it off, is a very good engineering control. Isolation, move people away from the hazard or move the hazard away from the people. Enclosures, placing the material process in a closed system, enclosed machines, booths, etc., which is kind of guarding it. Ventilation, use local exhaust or general dilution ventilation to remove or reduce airborne products. Mechanical lifting devices, use mechanical methods to lift or move objects instead of manual lifting. Guardrails, using guardrails to prevent a fall. Automation, the less workers have to handle or use the materials, the less potential there is for exposure. Mechanical transportation rather than manual methods. Now, with mechanical transportation comes moving parts and suits, so that creates other hazards. that you have to deal with. One of the best things about engineering controls is that they are almost always there. The operator doesn't have to do anything to keep these safeguards working. They may be more expensive initially than other controls, but in the long run, they are probably much cheaper. Again, here we are, engineering controls. Isolate people from the hazard. What you should know is this and these phrases that go with each one of these. You should know those by heart. Administrative controls change the way people work. Administrative controls are ranked lower than elimination, substitution, and engineering controls because this method does not necessarily remove or reduce the hazard from the workplace. These control measures have many limitations because the hazard itself is not actually removed or reduced. Administrative controls should be used in combination with other control measures where possible. Administrative controls must be well written, kept up to date, and all workers must be trained on them. Training must be done initially, periodically, when something changes, and when an employee indicates lack of knowledge. Many OSHA standards have requirements for training, so watch for them and follow them. Methods of administrative control include training. This is probably the most used administrative control, although not necessarily the most effective. But let's face it, everybody needs to have training on their job, no matter what it is, and safety should be part of that training. Written procedures to be sure that the work is done safely. In other words, you have a checklist or something, you have written procedures so that you know when they do this, they do it in the steps to make it safe. Use job rotation schedules or a work rest schedule that limit the amount of time an individual worker exposed to a substance. Implementing a preventive maintenance program to keep equipment in proper working order. Now that's important. Keep the equipment in a proper working order. More on training. Employee education and training on how to conduct their work safety is a critical element of any complete workplace health and safety program. Training must cover not only how to do the job safely, but it must also ensure that workers understand the hazards and risks of their job and the controls in place to protect them. It must also provide them with information on how to protect themselves and coworkers. Generally, training must be done initially before an employee starts working. When there's a change in the product, procedure, workflow, etc. When an employee indicates that they have not understood the training, and periodically, sometimes required by OSHA standards. And period required by OSHA standards. Now remember, OSHA standards are a minimum. For instance, I always required lockout training annual, which is any place that I was in charge of safety, that was a requirement on lockout. It's that important. Developing and implementing safe work procedures or standard operating procedures. Training and education of employees about the operating procedures, as well as other necessary workplace training. Establishing and maintaining good housekeeping programs. That's a good one. See, that's kind of down on the list here, but good housekeeping programs are good because guess what? A lot of people get hurt just walking across the floor. Preparing and training for emergency response for incidents such as spills, fires, or employee injury. Scheduling maintenance and other high exposure operations for times when fewer workers are present, such as evenings or weekends. Restricted access to a work area. Restricting the task to only those competent or qualified to perform the task. And again, in OSHA, that comes up quite a bit. Using signs to warn workers of a hazard. So we're down here at administrative controls. Change the way people work. Personal protective equipment. Protect a worker with personal protective equipment. Personal protective equipment is almost universally known as PPE. You could just say PPE to about anybody in the workplace, and they're going to know what that means. It's probably the most acronym, maybe after OSHA in safety. PPE refers to anything workers wear to help protect them from a workplace hazard. The use of PPE as the main method to control exposure should be limited to situations where elimination, substitution, engineering, or administrative controls are not practicable, or when additional protection is required because the other control methods are not sufficient to reduce the hazard, or the hazard is a result of a temporary or emergency condition. So you use PPE when the others just aren't going to work. PPE limits exposure to the harmful effects of a hazard only if the PPE is worn and used correctly. There's a big problem with PPE. People have to put it on. They have to wear it. They have to use it. Examples of PPE: eye protection, safety glasses, goggles, face shields, very important. hearing protection, earplugs, earmuffs, gloves, foot protection, safety shoes, skin protection, covers, overall aprons, coveralls, aprons, full body suits, respiratory protection. The choice of what type of PPE is required must be based on a specific hazard found in the workplace. No matter which type of PPE is used, it is essential to have a complete PPE program in place. More specifically, OSHA says the employer shall assess the workplace to determine if hazards are present or are likely to be present, which necessitate the use of personal protective equipment. Now, what I did at every place I ever worked, I just got with everybody, says, okay, what hazards do we have? Do we have anything that's, the noise? Do we have people who require safety footwear? Oh, yeah, like mechanics. Why do your maintenance people wear protective footwear? Because they're carrying motors and stuff like that, and they could drop it on their foot, right? The usual run-of-the-mill production worker probably doesn't need footwear, but you can go through all these things, and you can do one piece of paper for the entire plant and have it all. That's a good way to do it. When OSHA comes in, wants to see if you've done this. This is pretty simple. It can be one page broken down by area, machinery, job title, or all of these. We're going to cover PPE in a lot more detail later. So there's your hierarchy of controls. Again, elimination, physically remove the hazard. Substitution, replace the hazard with something less hazardous. Engineering controls, isolate people from the hazard. Administrative controls, change the way people work. PPE, protect the worker with personal protective equipment. Can more than one control method be followed? Sure. Sometimes a hazard cannot be controlled using a single type of control method. If a hazard cannot be eliminated, a combination of controls may be required. For example, using a scissor lift instead of a ladder as substitution. Workers should be trained on the safe use of the equipment and follow safe work procedures, administrative controls. When working in heights, workers should also use PPE, including a full body harness and lanyard attached to an anchor point if there's a risk of injury from falling. Now, you'll probably hear this many times. Here's the problem: full body harness and lanyard are fine when you're dealing with fall protection. Here's your kicker: anchor points. They just don't build anchor points into factories, which they should, but they don't. So you might have the best body harness on and lanyard, but if you don't have a proper anchor point, it's not very good. In fact, it's not worth it. It's probably not even. It's not legal, and it's maybe worthless. So it's the body harness and lanyard don't do any good without a good anchor point. Here's another example: driving in the winter for work. Controls may include not driving during extreme winter weather, elimination, determining if there are any other options to driving, such as public transportation, substitution, use of winter tires, engineering, and driver training, administrative. So there's a lot of different ones there. Should the adequacy of controls be reviewed or evaluated? Yes, of course. It's important to determine the effectiveness of the control methods implemented and adjust as required. Controls must not create new hazards. For example, if wearing PPE contributes to other hazards, such as heat stress, then it is important to review if other control methods are possible, or if additional precautions are needed. Monitor both the hazard and the control method to make sure that the control is working effectively and the exposure to the hazard is reduced or eliminated. Consider the following questions: have the controls effectively eliminated or reduced worker exposure? Have any new hazards been created? Are new hazards appropriately controlled? Are any other methods required? Are workers trained in the control methods? What else can be done to eliminate or reduce exposure? If there is a change in the workplace, does this impact the hazard or the control methods? Again, there's your hazards of hierarchy of controls again. Elimination, physically remove the hazard. Substitution, replace the hazard. Engineering, isolate people from the hazard. Administrative, change the way people work. PPE, protect the people with personal protective equipment. This is a valuable tool. Learn it and learn to use it. One day your company will bring in a new piece of equipment, buy another company, change a process, or something that needs to be addressed for safety issues. When you bring up the hierarchy of controls, you will lead the way to professional resolution of the situation. That's it. So, hierarchy of controls, very important.